on the review game. Are you guys in the house today? Yes, thank you. Everybody throw that out there. Yes, there's Maria. Everybody say good job. Give them some love. I'm going to do my best to highlight you guys and all the good things you are doing in our class. I don't expect perfection. I'm not just always going to reward people that get the highest score, but I was excited to get in and see who did our Nearpod assignments. In Nearpod, I can see everything you're doing. I can see who logged in. I can see who skipped things. I can see how you answered things. So I love Nearpod because there's so many options of fun things we can do, and it also gives me lots of data. It gives me lots of feedback on what you're doing in class. Yeah, no, it's okay. We're just learning. So if you skip something this time around, don't stress about it. Okay. I'm not mad at you. I realize it was a learning curve, but these two rocked our Nearpod assignments and rocked that review game, earning the highest amount of points. So I just wanted to recognize them today and let them know I'm super impressed. All right. And I just wanted to give them some love. So thank you for showing up and working hard. Yes, Maria is Angelo here? I don't know if he's here or not. And it's okay if they might be a little bashful, and that's okay too, because I can be pretty bashful myself. So yes, let's jump right in. Again, Class Connect Monday, Tuesday, Wednesday. And actually, I want to remove the Friday session. This Friday is a teacher work day, so I won't be available for a help session on Friday unless you're like, I'm dying over here, Mrs. Rittenhouse. I really need you. Okay. Then we can always, hey, he's here. All right. If you, I'm getting all kinds of private messages right now about skipping things. Don't stress. It's okay. I'm totally not mad. I am actually just super glad to see how many of you logged in and did it. Because really, when I give you things just because it seems like you're at home and it seems optional, rather it says required or not, ultimately you have the choice and the responsibility to show up and do these things. And so I'm proud of you. Proud of you for showing up, whether you ended up skipping things purposely or accidentally. We're doing this together and working through some new things. All right. So Monday, Tuesday, Wednesday, we are having class. Thursday is a help session. If you need me Friday, you let me know and we'll schedule something. Here's the right schedule. We looked at the wrong schedule yesterday. So today we're going to talk about chemical bonds and the chemistry of life. We're going to bring carbon in the picture today too. All right. Work on a little bit of chemistry. And then tomorrow we just have a very short quiz. How many of you are a fan of the short quizzes? Yeah? I'm definitely a fan of short. I'm all about getting to the point, right? I'm not here to just drown you in work, but I do want to know that you're here and that you're understanding things so that we can revisit things if for some reason we're not accomplishing what we think. You have board tools? Is that what you're talking about, Peyton? We are going to need board tools today. That's why it took me a little longer to get here today, because you guys are so much fun. So much fun. All right. Actually, and instead of me reading the goals today, does anyone want to read the goals for today? And remember, while you're here, at least one of the 3 days, I would love to see your face. All right, Peyton, will you read the first two? And Honesty, will you read the second two?
Can you hear me?
I can hear you.
Okay. What is a valence electron and why are they important? Why is carbon an important element? Why is it present in so many molecules? Thank you.
Good job. How about you, Honesty? Oh, I hear you're trying to get on the mic. I hear a little bit of static, but I don't hear your sweet voice. Is it not working? Let's give her a minute. Is there anyone else who would like to read those, just because I feel like she's struggling with her mic? We'll come back to you, Honesty, I promise. I need to help you work through those mic issues. Anybody else want to read for us today? Last two goals. Yep, we're just going to read those last two. Here, let me get my pointer. These last two goals. Oh, she's trying. You want to read them, Jasmine? I know, poor Honesty. She's trying.
What is the maximum number of bonds carbon can create? All organic compounds contain what element?
Thank you. I'm so sorry about your mic, Honesty. We'll get it fixed. Thank you so much, guys, for stepping up and reading those today. I love hearing your voices. You always get to hear mine. I just don't get to hear yours. Great job. All right, so we talked about this yesterday. We started into matter, right? We talked about matter being my little pumpkin plant. We talked about matter being my coffee or my cell phone. We talk about things that you're looking around your room and seeing, right? So the smallest living thing is a cell. And most of our course, we're going to be talking about all of that stuff, okay? But this, oh, you can't hear anything. Trying to think of what I can do here to try to help you. If you go to settings, Alana, maybe it'll let you do a visual. Try refreshing, exit and come back in. See if that helps. Okay. Yes. All right. So the smallest living thing is a cell, and the smallest non-living thing is an atom, right? Our friend Adam, who somebody thought I was talking about them yesterday. All right. Not that, but an atom. All right. An atom is the smallest living thing. You have a question not about today. Is it for the class or for me? You can send it to my private chat if you want. Okay. So today we're going to look a little bit deeper for the class. All right, go ahead and send it in chat. At the periodic table, and specifically at one element. Okay. We are going to look at an element that is important for all of life, all living things. There's one element on this periodic table. Okay. And that one it's like the mystery host of all living things. Do I have your interest piqued? Before we go there, though, before I introduce the most important guest, all of these elements on the periodic table, all of them, all right, are made up of three things. We talked about those three subatomic particles yesterday. And those are these: protons, electrons, and neutrons. I appreciate all you helping with Alana in the chat. All right. So you have protons, electrons, and neutrons. That's what make up our atoms. When you look at the periodic table, it's going to tell you all about those subatomic particles. All right. The element we are going to look at today is carbon. Can everybody type carbon in the chat? Carbon. Carbon, yes. So carbon is the element that is the most important element for life on the periodic table. Now, there are a lot of important elements, so we're not going to get into a debate of which is the most important. Okay, but carbon is going to be the most important element for living things. So we're going to learn about carbon today and those subatomic particles by looking at its box in the periodic table. Okay, so here's its name. At the top is the element name. All right, right underneath it is the atomic number. See that? This is the number of protons in the atom. The C is the symbol. All right, and the atomic mass is the average mass of the atoms in an element. All right, so today we're going to look at the atomic number. Everybody point to this atomic number right here. Yes. Look at Brianna. I love it. She knows the Latin word. And Alana, if you're having a hard time and it's not going to work for you today, if you can't hear, which I guess you can't hear me say this, you can watch the recording. All right. Awesome. So that atomic number tells us the number of protons. It also tells us the number of electrons. And yesterday we were looking at electrons and bonding. All right, we looked at 3 types of bonds. Can someone jump on your mic and tell me one type of bond we talked about yesterday between these elements, between these atoms? So carbon forms bonds with other elements, and there's 3 types of friendships they can have. Somebody just pop on your mic.
A hydrogen bond.
Hydrogen bond. All right. So hydrogen bonds. What do we know about hydrogen bonds? There's one thing I want you to remember about hydrogen bonds from yesterday. What is it? Yes. High five. Everybody type they're weak. Or H equals weak. Hydrogen bonds are weak. They're the weakest bond. Does that mean they're not important? No. It does not mean they're not important. They actually may be the most important bond because they're so weak. Okay? Awesome. So we have hydrogen bonds. What's the other type of bond? Somebody pop on the microphone. What's another bond we talked about yesterday?
Ionic bond.
Ionic. What does ionic do? Yeah, is JB in here? I don't think I've seen JB today. He said yoink. Right? They steal. Right? So everybody type steal, take, or ionic equals steal or take. All right? So hydrogen, they're super weak. All right? Hydrogen are weak. Ionic, steal. What about covalent bonds? Oops, I just told the last one. Kensley, yes. Covalent bonds, what? If there is a covalent bond between 2 elements or 2 atoms, 2 non-living pieces of matter, good, they share. What do they share? Everybody type share for me. I only see a couple shares. Mrs. Reynolds, I'm awake. Yes, Nevaeh. They share electrons. They share electrons. So today we're going to look at how elements share electrons in these bonds or take them. All right. And what that looks like and why is carbon like the superstar? All right. This is carbon. All right. This is called a Bohr's model. You'll probably take chemistry at some point, or you should because chemistry is so good. But this is what we call a Bohr's model. All right. And in carbon, let's go back one slide for a minute. How many electrons are in carbon? Electrons and protons have the same amount. So look at the periodic table. Yes. Yes, 6. So there are 6 protons. The protons are in the very, very middle. So the protons are hanging out here in the nucleus of our atoms. But our electrons, they are what we do. They're like on our egg plate that we talked about yesterday. If you didn't see yesterday's lesson, you'll watch it online. Okay? It's like our egg plate. It's being full. So there are different layers around, or shells around, the nucleus. The first shell only holds 2 electrons. All right? So we see in carbon 1, 2, that first electron shell is full. What do you do when it's full? You add another shell. Okay? And in that shell, you can see that we have 1, 2, 3, 4 electrons. Each one of these dots represents an electron. All right, let's go ahead and label those for you. These are electrons. Okay. And what do we use to bond? What do atoms use to bond with other atoms? They share or steal electrons. Yes. Yes. We share or steal electrons. So this is actually what makes carbon such a nice friend. So yesterday we talked about friends and bonding. We talked about friends that like are awesome and they're there for us and they share, we give to them and they give back. We talk about friends that like are just takers. They always take our things. Somebody said they take your $5 and never give it back. All right. That we talked about them like this. With carbon is like not only like a nice friend, all right, but carbon has the ability to have lots of friends, all right, because you see, in order for carbon's egg plate to be full, it needs 4 more electrons. So this first shell, you only need 2 electrons. But in the second shell and the third and fourth and every shell after that, you need 8. You get 2 electrons basically at 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock. All right, so you see carbon needs 4 more electrons to get a full egg plate, to get a full shell. So this is what I feel like represents carbon, all right? You got a little plug. It's got an outlet or like a seat at the lunch table for 4 friends. All right, so carbon is stable and like a stable friend, and there are 4 slots for other atoms to bond. It's a bondable friend. I know, right? I need myself a carbon too, Sarah. A good friend that is accessible to many friends. That's how I like to think about carbon. So let's look. These are other diagrams, okay? So like lithium needs like a huge ton. Like it needs what? 7 electrons. That's like almost overcrowded. How many electrons does fluorine need to get full? To have a full egg plate? It's got 2, 4, 6, 7. Yeah, it only needs 1. So like fluorine's kind of that person that like is just like, I need one bestie and I'm good. You know, it doesn't have a lot of room. Maybe is a little cliquey. Right? It doesn't have room for, or doesn't want a lot of friends. All right, we look over here at aluminum. Similar to carbon, right? Similar instead of needing 4, how many valence electrons does aluminum need? Yes. See, you guys are chem rock stars. When you guys say chemistry, you're going to thank me someday. And you're like, Mrs. Rittenhouse already taught me this. All right. So let's do it. Can we practice? Does anybody care if we practice? All right. So I actually probably need to pull up a periodic table because I didn't put that on the slide. And I don't think I can copy and paste a photo onto here. So I might have to tell you. Oh, now it's not pulling up a periodic table. It was like, do you want to buy one on Amazon? No, I don't. I don't want to buy one. I just want to look at a periodic table. Here we go. Okay, so who wants to volunteer to, okay, hydrogen. Okay, hydrogen only has 1 electron. Is there anyone who will go out on a limb for me here? And stick 1 electron. I'm going to put the amount of electrons they have right down here on this line for you. Usually you would look at the periodic table and look at that atomic number and it'll tell you. So for hydrogen, I know that I need 1 because the square, just like, let me go back to that slide really quick. Just like that square on the periodic table for carbon, see, if I go to the periodic table, it tells me how many electrons there is. Yeah, no, that was a seriously great question. All right, so I'm going to tell you what that atomic number is because I'm silly and didn't put a periodic table down here for us to look at. So hydrogen needs 1 electron. So what we're going to do is go to our tools and take different ones of these and look, ta-da! You could put it really anywhere, but that's what the Bohr model for hydrogen will look like. It's just got 1 dot on that very innermost valence shell, 1 electron. See, it's not so bad, right? Okay, so let's look at oxygen. Okay, oxygen has 8. Oxygen has 8. Does anyone want to do oxygen? Oh, Xavier's got it. So what I'm thinking that I would love for you to do is whoever raises their hand and chooses this, I will just put these numbers up here for you, Kaden, because nope, all the periodic tables are exactly the same. So they'll all have all these, every single periodic table will tell you the same thing about every element. All right. How do we know that it has 8 again? Sorry, I should have put this on this slide. Right here. Okay, so carbon only has 6. Carbon only has 6 electrons, but every element, their identities, here, okay? See all these dots in the corner? See those? Those are, if I could blow this picture up, are the atomic numbers. They tell you how many electrons and protons are in a hydrogen atom, or in, like, let's say, a lithium atom, or in a silver atom, or a zinc atom. Okay, all of these squares represent 1 atom. Okay. And all carbon atoms, they all have the same number of protons. All gold, silver, hydrogen, oxygen, helium. If it's a helium atom that has that number of protons and electrons, it's kind of what gives it its identity. All right. Are these atomic numbers. So what I'm going to do for you while we make these diagrams is I'm going to take the atomic number from the periodic table and I'm going to put it right here. And what I'd love for you guys to do is to use your pencil tool or the little round dot tool, and we're going to put them on the valence shells. So let's do maybe oxygen together. So it has 8. So we do 1, 2, and then that shell's full. Okay? So let's move this one right here. Yep, no, you're fine. Into the next shell. Let's go to the next shell. Whoever was doing the dots, go for it. Do it again. So we have 2, and we need to add 6 more. So 1, 2, 3, 4, and then put another one up here, 5, 6. Anyone feeling brave? Great, watch. 1, 2, 3, 4, 5. And look how pretty my circles are. 6. That doesn't matter though, right? So we can look. Oxygen's atomic number is 8. That means it has 8 electrons. Don't be too confused. Okay, we have 8 electrons and 8 little dots on our diagram. Does that part make sense? Andrea, does that help? Okay, let's look at the next one. It doesn't need to be, you don't have to do dot diagrams on anything else. I just thought it would be kind of fun. So let's look at sodium. I'm going to find sodium for you. It is, I'm looking on the periodic table because I don't know this stuff. I don't teach chemistry. Oh, okay, so sodium has 11. Sodium has 11. So we need to put 11 little dots. Why is that not working? Down here. There we go. On. So the very first circle, we just want to put 2. We are making 11 little dots around the nucleus of sodium. You ready? I might use my pencil this time because those dots were not good. 1, 2. Now I'm going to move the next shell. 3, 4, 5, 6, 7, 8, 9, 10. Oh no, that shell's full. So I go to the next one, 11. Just go around the clock, right? 12, 3, 6, 9, 12, 3, 6, 9. And then when you run out, you go to the next shell. Are we feeling a little better? Anybody? Giving you a poll. Let's do this last one together, unless there's somebody that's like feeling strong. Let's do chlorine, right? Good old chlorine keeps our pools nice and clean. Oops, wait, I forgot to look at it. 17. 17. Those aren't feeling too bad. I'm impressed. So we have 17 dots. 2 go in that very first shell, and then we add more all the way around. Any volunteers? Oh, Caden pulled out his periodic table. Smart guy. Anybody? Ooh, I got somebody doing it. This is making me so happy. All right, good. So 2 on the first shell, and then we go to the second shell. Yep. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Who was that? I guess I can look, right? Caden! Everybody give Caden a round of applause. So brave to attack something that is somewhat scary and new. Everybody claps. The crowd goes wild. So the most that goes in a shell is going to be 8, and then you move to the next. 2, 4, 6, 8. 2, 4, 6, 8. Awesome. So we did all that just because I thought you guys are so good at using board tools and talking. All right, but carbon, we come back to carbon because if you hated that, don't worry, because you don't have to deal with that anymore. All right, the biggest thing to know is that yes, the carbon has certain amount of electrons, and that is what makes it such a good friend. If there's a slide to save, this is a good one to me. I made this picture myself. Okay, because it just helps me remember that there are like 4 places. See, there's 4 on this valence shell. So I'm going to use a green pencil, I think. Maybe. All right. These are available places for a bond. I'm going to make them bigger because the other ones are green. There are 4 available places for carbon to make friends. All right. It's not too many. It's not too few. It's like it makes carbon the perfect friend, the perfect molecule to bond with. And that is why there are so many things. In fact, I want you to look at this word. Whoa. What word is this? Type it in chat. I'm getting crazy today with all my drawing. What word did I just? Yeah, all. Time out. All? Yes, all life. Anything alive. Type something alive in chat. Anything that is alive has the element of carbon in it. You, my friends, you have a carbon in your bodies, in your skin cells. Carbon. So what element makes all living things? If it is alive, it has carbon in it. We are going to do this tomorrow. We're going to start, or next week, we are going to start looking at 4 compounds made of carbon that are super important for life. But for today, you are lucky ducks. You don't have to look at any more of this. Also, I want you to know that if it's living, you know it's made of a carbon atom. Okay? I spent too long on our little diagrams. So we are going to end class because, hello. All right, it is time. The quiz is not due till tomorrow. Okay, so don't stress about that. We're going to come back and finish some of this up tomorrow. Is there one of these? Let's do this question, this last question as you exit the room, if you don't mind. All right. What one of these on the side is a carbon atom? Which one of these? A, B, or C? Remember that perfect friend. It has 4 openings. You guys make me so happy. Yes, 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 and yes. You guys are wonderful. You did a great job today. The only thing I missed today is some of your faces. Okay? Pop on your webcams tomorrow like me. Okay? And I will be here if you need me. So stick around if you have questions. You are free to leave. Class is over. Great job today doing some deep stuff. I'm proud of you. Have a great Tuesday, and I'll see you in the morning. So the Nearpod codes, they should be in the announcements underneath the Nearpod lesson. And yeah, you can always go back and do those if you want. If not, they're in the past to me. So if you feel like you're like, oh, I let you down, Mrs. Reynolds, it's okay.